Hey everybody, we're starting a new topic in finite math. We're done studying sets. We will apply sets later on, but we're done studying sets. Now we're going to talk about logic. And the basic building block of logic is something called a statement. So we've defined a statement here. A statement is a phrase or a sentence that is either true or false, but not both. A phrase or a sentence that's either true or false, but not both. So let's look at some examples. I weigh exactly 98 pounds. Well, maybe I do weigh 98 pounds and maybe I don't. It's either true or it's false. If I do weigh 98 pounds, then this is true. If I don't weigh exactly 98 pounds, then this is false. And I think it's false. But the fact that this sentence has to be either true or false, and it can't be both, means that this is a statement. Here's another example. The moon is made of green cheese. Well, either it is or it isn't. This sentence is either true or it's false, and not both. So this is a statement also. Now, our last example. Close the door. Is it true? Is it false? This sentence is neither true nor false, so it's not a statement. Just a little bit more on statements in a second. Back with some more examples. Statements can be categorized in different ways. One way that we can categorize a statement is to say that it is compound or that it is simple. A statement is compound if it is made up of two or more other statements. And here we have an example of a compound statement. Here's one statement. And here's another statement. So this whole statement is made up of two other statements. So this whole statement is a compound statement. Let's look at it. We will go to the beach and we will have a good time. That's a compound statement because it's made up of two other statements. It's made up of the statement, we will go to the beach and we will have a good time. And these are statements, right? We will go to the beach. It's either true or it's false, and not both. And we will have a good time. It's either true or it's false, but not both. So the simple statement, we will go to the beach, I beg your pardon. The statement, we will go to the beach, and the statement, we will have a good time, are put together to form this compound statement. We will go to the beach and we will have a good time. So a compound statement is a statement that is made up of two or more other statements, like this one. This compound statement is made up of the statement, we will go to the beach and we will have a good time. Now let's look at a statement that's not compound. A statement that's not compound is simple. It's not made up of two or more other statements. A simple statement cannot be decomposed into two or more other statements. Here's a statement, we will go to the beach. It's either true or it's false, isn't it? Either we will go to the beach or we won't go to the beach. And it's not both true and false. So this is a statement. But is it made up of any other statements? No. This is a simple statement. Now we may have noticed that this compound statement is made up of two other statements, and each of these statements is simple. We will go to the beach, that's a simple statement. We can't break this up into two or more statements. And this statement, we will have a good time, is a simple statement. We can't break it up into two or more other statements. And so this compound statement is formed by joining two simple statements together with the word and. So the next thing that we want to talk about is, how do we create a compound statement from simple statements? Here's a remark. Compound statements are created by joining two or more simple statements together using connectives. So we create a compound statement by joining two or more simple statements together using connectives. Let's look at our old example again. We will go to the beach and we will have a good time. The simple statement, we will go to the beach, and the simple statement, we will have a good time, are joined together by the connective and to form a compound sentence. We will go to the beach and we will have a good time as a compound statement. Yes, a compound statement. And it's formed by joining the simple statement, we will go to the beach, and the simple statement, we will have a good time, by the connective and. Here's another example down here. You will repair my car or you will buy me a new one. Okay, here the connective is the word or. And it joins the simple statement, you will repair my car, and the simple statement, you will buy me a new one. It connects these two statements with the word or. So this is a compound sentence or a compound statement joined by the connective or. And we have one other connective that's commonly used. That's the word but. Let's look at an example. One more example of a compound statement. We played a good game, but we lost. The word but is the connective, and it joins the simple statement we played a good game with the simple statement we lost. We played a good game, but we lost is a compound statement formed by using the connective but. I guess the next thing we have to talk about is the truth value of a statement. And every statement has a truth value. The truth value of the statement is either true or it's false. If the statement is true, then the truth value of the statement is true. If the statement is false, then the truth value of the statement is false. So let's look at some examples. I weigh exactly 98 pounds. No, that's not right. Let's see. I weigh exactly 98 pounds. No, I don't think so. So the truth value of this statement is false. Let's look at our next statement. Alabama is the largest state in the U.S. Well, whether we talk about geographical land area or population, doesn't matter. This is not true. So the truth value is false. Well, hey, maybe we'll get a true statement down here. Alabama is east of Mississippi. If we look on a map, we'll see that that is absolutely true. So the truth value of this last statement is true. Most often when we write the truth value of a statement, instead of actually writing the word true or writing the word false, we'll just use capital T for true and capital F for false. Now that we've talked about truth values of statements, I guess the next thing that we need to do is talk about the negation of a statement. And we'll do that right now. Okay, Next, we explore the concept of the negation of a sentence, or negation of a statement. A statement can be modified in such a way that the truth value of the modified statement is the opposite of the truth value of the original statement. Let me read that again. A statement can be modified in such a way that the truth value of the modified statement is the opposite of the truth value of the original statement. And we call the modified statement the negation of the original statement. So if the original statement is true, then the negation is false. But if the original statement is false, then the negation is true. So let's look at an example. I weigh exactly 98 pounds. I'm not saying I do, I'm not saying I don't. But I weigh exactly 98 pounds. How would I modify this statement to get a statement that has the exact opposite truth value? Probably by inserting the word not in here somewhere, right? For example, maybe I can write this. I do not weigh exactly 98 pounds. So let's see. If the original statement is true, I weigh exactly 98 pounds, then this statement, I do not weigh exactly 98 pounds, is false. Okay, that looks good. Now, suppose this statement is false. I weigh exactly 98 pounds, that's false. Well, then isn't it true that I do not weigh exactly 98 pounds? So either way, the negation has the opposite truth value that the original statement has. Let's see, what other examples could we look at? Okay, I like science fiction. Here's my statement. How do I negate that statement? How would I modify this statement to get a statement that has the exact opposite sense? It probably has something to do with the word not, right? So maybe we'll write something like, I do not like science fiction. So if this statement is true, I like science fiction, then this statement, I do not like science fiction, is false. Works so far. Now, if this statement is false, I like science fiction. If that statement is false, then it's true that I do not like science fiction. Okay, so whatever the truth value is of the original statement, the truth value of this statement is the opposite. So this is the negation. And maybe one more example. Alabama is the largest state in the U.S. How do we negate this? Probably again using the word not, and all we have to do is insert the word not right there. Okay, so we got our negations down pat. What's next? Maybe what we should do next is develop a more convenient style of notation. That's next on our agenda. Okay, for ease of notation, we get into what we call symbolic logic. And we read, for the sake of simplicity, simple statements are often represented by lowercase letters, P, Q, R. The words and but are both represented by this symbol, an upside down V. The word or is represented symbolically by this thing that looks kind of like a V. And then this squiggly line right here, if it appears before a statement, has the effect of negating the statement. Let's do some examples. Here's our example. And when we see this, we interpret it this way. Let P be the statement, I will order a meal. Let Q be the statement, I will order a soft drink. So we're representing the statement, I will order a meal, with the letter P. We're representing the statement, I will order a soft drink, with the lowercase letter Q. So, This statement in symbolic logic is read P and Q and is interpreted, I will order a meal and Q, I will order a soft drink. So this is the statement P. This is the statement Q. And the word and is represented symbolically with this upside down V. P and Q, which is what we started out with. P, I will order a meal, and Q, I will order a soft drink. Okay. Let's try another one. I think I better move this down a notch. P, let's see, this thing that looks like a V, this is or, isn't it? P or Q is interpreted P, I will order a meal. This thing is or. And Q, I will order a soft drink. And let me diagram this. P is the simple statement, I will order a meal. Q is the simple statement, I will order a soft drink. And or is represented by this symbol. Now, let's try one more. Logically, this is read not Q. And here's how we interpret it. Remember what this symbol does? It negates the statement that follows it. Q is the statement, I will order a soft drink. This symbol negates that statement. So what's the negation of I will order a soft drink? Maybe I will not order a soft drink? So we would represent that symbolically as not Q. This will end our lecture for today. In the next lecture, we're going to build on this symbolic language, this symbolic logic. But we've seen the beginnings of it. Let's review this carefully, mull it over, and when we get accustomed to this symbolic logic, we will build on it and embellish it and enhance it.